Welcome back to my channel for a very special photography episode. And what I want to do in this video is I want to provide a first part of my comparison between the Leica SL3 and the Hasselblad X2D. And a lot of people in the comment section below videos on my channel, whenever I talked about the Leica SL3 or the Hasselblad X2D, which both are the newest system cameras from Leica and Hasselblad, people asked, can you not do such a comparison? And I honestly refuse so far. I didn't want to do it. And why do I think this is a delicate matter? Because in the Leica SL3 we have a full frame sensor, and in the Hasselblad X2D we have a larger medium format sensor. And I personally think comparing cameras with different sensor size is really a delicate matter and is never easy. And that's also the reason why my comparison comes in two parts. This is part number one. In this part I will lay out the foundation how to compare these two cameras when it comes to image quality. Because here we have a larger sensor, here we have a smaller sensor. I will explain in this video my choices of what lenses I'm using for my review, what aperture setting, what shutter speed setting, what ISO setting, all of that. It's a lot of technical stuff that will roll over you in this video, and I apologize already because you will see a lot of formulas. But I think it's important to lay out a proper foundation before then in the second part of my comparison, which I will post in a couple of days, I will do the true comparison between these two cameras, looking at design, for instance, looking at functionality, handling, menu structure, the way you operate the camera. I will look, of course, into image quality and use everything I worked out in this video here in part one. And I will provide a full comprehensive comparison of these two cameras so that at the end, if you have watched both videos, you will be able to make a decision. Is the Leica SL3 my go-to camera, or is it the Hasselblad X2D? Let's kick this off. Let me start part one of my comparison between the SL3 and the X2D with some housekeeping. First of all, I know these two cameras very, very well. I've posted tutorials on the handling, I've provided tips and tricks, I've shot them with different lenses. You'll find a lot of video material on my channel which deals either with the X2D or the Leica SL3. I also think that both cameras are absolutely fantastic instruments for professional photography, and I will talk about design in part two, but these cameras, they have a lot in common and at the same time exhibit a lot of differences. And the image quality coming from both cameras is something of the best you can get in photography these days. Of course, there are the Nikon cameras, there are the Canon cameras, the Sony cameras, the Fuji cameras, Fuji in particular in the GFX series also playing in the same sensor size camp here. But these cameras, they mean a lot to me. They've been with me on travel, they've been with me in shooting locations, and I love them both. I never made a decision for one and then got rid of the other one. And I will continue to keep them both and post content on these two cameras and also on the evolution, in particular on the Hasselblad X2D. And that's something I will comment on later in part two. There is still a lot of firmware improvement outstanding in my opinion. And we'll talk about that in detail in part two when we talk about autofocus and features. So rounding this all up, what I want to achieve in this video, and this will involve, as said at the beginning, a lot of mathematical calculus, is how to compare them. And if you look at them, currently here is the brand new 25mm lens mounted. By the way, I think I owe my community a review of that lens standalone, which I will do in the next weeks. And it's a 25mm lens on a medium format sensor. And here I have mounted the super aposumicron 21mm on a full frame sensor. And these choices are not by chance. They are not arbitrarily made. And I will explain in this video why I compare on a full frame sensor a 21mm lens with a medium format sensor shooting a 25mm lens. And we'll also talk about the settings and then achieve a holy grail image, which means I will shoot Jennifer here in front of me on the table with this combination of lens and camera and this combination here, and you will see these images are exactly the same in terms of depth of field, in terms of field of view, and also in terms of aspect ratio. And that's what some people call the holy grail in photography if you deal with sensors with different sizes, and that's exactly what we'll achieve in this video. And then in part two, as I said, I will move on and really do step by step a proper comprehensive comparison. As a little motivation for what's about to come, but also because it's fun, let's do a little quiz at this point in time. So here you see two images of Jennifer in front of me on the table. Which side belongs to the Hasselblad system and which to the Leica system? Left-hand side Leica, right-hand side Hasselblad, or vice versa. I want you to pause here the video for a moment. Make up your mind, come to a conclusion and decision and drop me a comment. And don't cheat, because I will show in a moment which picture is from which camera system. So drop me a comment, let me know what you think. Left-hand side Leica or left-hand side Hasselblad? So here's the solution, and you see that on the left-hand side, that image is actually shot with the SL3 and the Super Aposomicron 21mm, and the right-hand side is from the Hasselblad X2D 100C with the 25 XCD lens. So who played that game in an honest and fair way came to the right conclusion? Again, drop me a comment, let me know what did drive your decision. Did you really come up with the left-hand side is Leica and the right-hand side is Hasselblad? Or was it vice versa? And again, what did drive your decision? I'm really curious to learn about this, because in the fan community of the Leica camp and the Hasselblad camp, there's typically this debate going on. The Leica fans say there is this unique Leica look. There is no other camera system that can produce that particular unique Leica look. In the Hasselblad camp, people are swearing that the Hasselblad natural color solution is the best on planet Earth. And I can tell you, these two images, they are very easy to be mixed up in terms of source of gear. Was it a Hasselblad system or a Leica system? What we'll do now in the next minutes, well, it will be quite some minutes, I guess, discuss how I came up with this, what I called before, holy grail picture, shooting with two camera systems with different sensor sizes, the kind of exactly same picture. I will go through my material fairly quickly, but if you need more time at any time, please pause the video, stare again at the content, think about what I said, and then hopefully come to the same conclusions. Let's start with field of view, and it starts easy and I hope with common knowledge. So field of view is determined by two parameters. It's the focal length and, attention here, the sensor diagonal. Of course, the sensor size plays a role when we talk about field of view. A few rules of thumb are the following. The longer the focal length, the narrower the field of view. That's why a focal length longer than 50mm typically is a telelens. The shorter the focal length, the wider the field of view. That's why we call this a wide angle lens. And typically it starts just about 40mm and shorter. And if we are between 40mm and 50mm, in particular close before 50mm and 50mm, we call a lens of this focal length a normal focal length, and that corresponds roughly to the field of view of the human eye. That's why it is always perceived as very pleasant. If we are comparing two sensors with different size at the same focal length, then the smaller the sensor, the narrower the field of view. The focal length, and that's important to bear in mind, does not change with sensor size. It's a physical property of the lens. Never again think that just because you mount a lens with a certain focal length on different sensors with different sizes, that the physical property which is described by the focal length is changing. That never happens. Let's become more specific now, and let's look at the Super Aposomicron SL21 on the SL3 and the XCD25 on the X2D. And of course there is some mathematics underlying the field of view. And the way to calculate this based on the two parameters I mentioned before, focal length and sensor diagonal, is 2 times arcus tangens sensor diagonal divided by 2 times the focal length. And we have a focal length for the Leica lens and the Hasselblad lens, but what is the sensor diagonal? That's still something we need to figure out. Now, I've shown this many times on my channel. It's easy to calculate. We have a full frame sensor on the left-hand side on the SL3, 36 times 24mm. We have on the X2D, let's say a 44 times 33mm sensor, and the sensor diagonal of the Leica then turns out to be 43.27mm, and on the X2D it's 54.78mm. If we feed this then into the formula, now having all the parameters ready, we actually end up at 2 times arcus tangens and then the parameters for the Leica and then the same for the Hasselblad. And if we go to the web and do this via Wolfram Alpha, we get actually for the Leica camera a field of view in degrees of 91.7 degrees. And we can verify that in the specification sheet of the Leica lens, which I did here. And you see the view angle or field of view, if you want to call it in that way, is in the diagonal dimension 91.7 degrees, which is exactly what we calculated here. So that the math seems to be correct. Let's do the same for the Hasselblad. We end up at 95.22 degrees. And also here, going into the specifications, we find 95 degrees on the diagonal field of view as specified by Hasselblad themselves. So that looks good. If we get this all together, we have not exactly the same, but kind of a comparable field of view now. And that is for the time being the best I can offer. And let me quickly explain why. Let me quickly explain my lens choices here. Why 21mm Super Aposummicron on the Leica SL3 and the new XCD25 on the Hasselblad X2D? Well, you saw that the field of view is not exactly matching. We have 92 degrees here and 95 degrees here, as I just elaborated in my presentation. But nevertheless, I decided for these lenses. Now, first of all, it's not straightforward on different sensor sizes to come up with lenses which then generate via the crop factor the equivalence on the field of view. And there will always be some deviations. In another video I did some time ago where I compared the Hasselblad X1D Mark II and the Leica SL2, I did choose for the Leica the 35mm Aposummicron, and I did choose for the Hasselblad the XCD45 widest open f3.5. Now, in the meanwhile, the scene has a little bit changed because, let me get this a bit more away, because with 45mm I have another choice on the Hasselblad side, namely the 45p. And I thought it's a bit delicate to go for an Aposummicron, which is in the Leica universe the best of the best, and then not being really decisive what 45 lens I want to have. Here the field of view would have matched better, and with a smaller difference between the angles on the two camera systems. But I nevertheless wanted to have the other two lenses. Let me outline in a moment why. Another option to actually get an exact match of the field of view is to go for zoom lenses. And of course, on the Leica system, I could go for the 24 to 90mm lens or the 24 to 70mm lens, which is the newer one. And on the Hasselblad side, I could go for the standard zoom, which we have in the X system, which is the 35 to 75mm zoom. And I've reviewed this lens on my channel. This lens people have seen several times on my channel. Both are excellent lenses. With these two zoom lenses, I would be able to achieve a perfect match because I have a continuous spectrum between 24 and 90mm here and 35 and 70mm here, and I can just choose on both lenses a focal length so that the field of view, with respect to the calculation I showed before on the field of view computation, is exactly matching. But with a zoom lens, some people will argue, you never achieve the optimum in terms of image quality. It's always better to go for prime lenses, like here for an Aposummicron 35mm or here for an XCD45. That's at least what some people will say. I personally think and found in my reviews that these zoom lenses are almost or maybe as good as prime lenses at each focal length. I really like the image quality coming from these lenses, but it will trigger a debate. I didn't want to have that. So I actually did not go for these lenses and went for the 21mm Super Aposummicron on the Leica SL3 because that's, in my opinion, the best lens you can have for landscape, architecture and reportage photography on the Leica SL3, period. It's also one of the newest lenses we have in the Leica SL system, and therefore it incorporates the newest technology, the newest insights from the Leica engineers. And the same applies here to the 25mm lens from Hasselblad. That's the newest lens we saw in the X system coming to market, and that's clearly an absolutely brilliant, excellent prime lens. And that's why I thought, in order to get a fair comparison, let's take these two lenses and let's accept that we have not a perfect match of field of view based on 21 on full frame versus 25 on medium format sensor. That's the rationale behind my thinking here. Returning to our presentation, we can now easily figure out the crop factor, and we have to solve that equation you see here in display. And if we fill in the numbers, it looks more familiar in this form. And the only unknown in this equation is actually the crop factor, which takes us from the Hasselblad sensor to the Leica full frame sensor. And everything drops off here, except at the very end we see that the sensor diagonal of the full frame sensor divided by the sensor diagonal of the medium format sensor is the crop factor, and it's the well-known number of 0.79, which I have mentioned on my channel so many times when looking into Hasselblad cameras and Fuji GFX cameras. Let's summarize where we are so far. So we have found that the 21mm lens on the Leica system and the 25mm lens on the Hasselblad system yield about a comparable field of view of 92 degrees on the Leica and 95 degrees on the Hasselblad. That difference will not be noticeable in practical terms. And I also just explained why I have decided for the Super Aposumicron and for the XCD25 on the Hasselblad system. So we have actually taken care in this way of the field of view perspective to make them kind of equivalent on the two camera lens combos. Now the next topics are, of course, what apertures do I want to use on the two camera systems and lenses? What ISO values? We'll look into the light triangle for this. And how can I make sure that auto-white balance is not changing the appearance of the images in a way that it becomes confusing? So we'll systematically decide on the shooting parameters now in the next few minutes. Now, since I will shoot Jennifer from a close-up distance, I decided on the XCD 25mm to go for an aperture of f8. And that automatically determines that on the Aposumicron SL, I need to use an aperture of f6.3. Why is this so? Well, we just calculated the crop factor to migrate from the larger Hasselblad sensor to the smaller full-frame sensor in the Leica SL3 as 0.79. And if I take the aperture I've chosen on the Hasselblad system, f8.0, multiplied with 0.79, I end up at an aperture of f6.3. Simple like that. Of course, there is also an intuitive explanation. If I have one focal length lens and apply it to a larger sensor and a smaller sensor, on the larger sensor I immediately get a shallower depth of field at the same aperture setting. And that means the crop factor of 0.79, which intuitively makes perfectly sense, scales the aperture for the smaller sensor towards a wider open setting. Simple like that, right? Now, for calculating depth of field, there is an even more complicated mathematical calculus underlying than what I just illustrated and showed on the field of view. And I have a very long video on my channel from some years back then where I compared the X1D Mark II with the Leica SL2. And I will now shortcut this and just refer to that video because there you find all the formulas, all the math, how to calculate the hyperfocal distance, how to use the circle of confusion of the different sensors, and how to come up with a mathematical way to approach how to calculate the depth of field. I'll not do this here because it makes the video unnecessarily long and it's just repetitive to something I already posted. I will instead shortcut and will use the app PhotoPills on iOS on my iPad to make some calculations. And here's the first screenshot. This is for the Leica SL3. I did fill in the focal length of 21mm, aperture setting of f6.3, subject distance, as I said, close up 0.4 meter, and then the app calculates for me all the parameters which are related to depth of field, the hyperfocal distance, the depth of field near limit, the far limit, the depth of field as a range, and so on and so on. And you also get some nice illustration how this all works. Now I did the same, of course, now for the Hasselblad X2D 100C, but did fill in a focal length of 25mm, an aperture of f8.0, but the same subject distance of 0.4 meters. And also here I get calculated all depth of field related metrics I want to know when dealing with this topic. And if we compare them now side by side at a focusing distance of 0.4 meter and the two different aperture settings, which I just wrote on the screenshot here to remind you what it was, we see that, for instance, the depth of field near limit on the Leica is 0.34 meter, which is exactly the same on the X2D lens and the X2D sensor. And the far limit is 0.48 meter on the Leica system and 0.49 meter on the Hasselblad system. And then taking into account some rounding, we see that depth of field is also actually about the same. It will not be exactly the same because we already have the difference in the field of view. We saw 92 degrees versus 95 degrees, and also here we have a little bit of a difference, but it is comparable, and as you saw in my little quiz when we started the session, it's not noticeable with your naked eyes. Next, I want to decide on ISO values manually set on the cameras. And normally if you look into equivalence videos, comparison between medium format and full frame or full frame and APS-C, people apply the crop factor, which is 0.79 squared, do some voodoo and magic, and then they come up with an ISO value. And what typically happens is that on the smaller sensor, you will apply a smaller ISO value because cameras with a smaller sensor, they are more vulnerable to noise. And the ones which have a larger sensor, they are less vulnerable to noise. What I will do, I will follow a slightly different path here for my comparison. I want to shoot both cameras at their native, respectively base ISO. And what does that mean? So Hasselblad calls the hardware sensitivity of the sensor the native ISO, and Leica calls it the base ISO. And on the Leica SL3 influencer event in Wetzlar on the Leica campus, Steph mentioned that the SL3 has a dual ISO on the sensor, namely 100 and 400, and a base ISO of 100. And what actually means native and base ISO? It both addresses the same property of a sensor, namely the physical hardware ISO sensitivity of the respective sensor, and any ISO value which is lower or higher than the native/base ISO comes from a signal attenuation or amplification. And I want to go for the native ISO on the Hasselblad and the base ISO on the Leica because that's typically yielding the best image quality. Hasselblad actually publishes the native ISO of the Hasselblad X2D sensor and specifies it as an ISO of 64. And for the Leica SL3, I already mentioned the dual ISO, which was an answer to a question I asked at the influencer event and the Q&A session at the Leica campus in Wetzlar back then when the SL3 was introduced, and it has a base ISO of 100. So we have now target choices in order to get the best noise-free image quality, highest dynamic range. Namely, for the Leica SL3 I want to go for an ISO of 100, and for the X2D, I want to go for the native ISO of 64. Now, if we look into the light triangle on the left-hand side for the Hasselblad, on the right-hand side for the Leica camera, what does that mean? We have fixed already the aperture. I want to shoot on the Hasselblad system with f8.0 and naturally then have to shoot on the Leica system with an aperture of f6.3. Let's for a moment assume that my shutter speed on both camera systems I dial in the menu is 0.5 seconds. Now I want to have on the Hasselblad the native ISO of 64 and on the Leica system the base ISO of 100. So how can I be sure that these light triangles are compatible in terms of exposure? And they're not, because what we would normally do is we would compensate in the light triangle on the right hand side for the Leica system for the wider open aperture of f6.3 by a smaller ISO value. I already mentioned this before when I said that smaller sensors typically are more vulnerable to noise. That's why in a comparison you typically apply a smaller ISO setting to the smaller sensor. And there's a formula to calculate this, which you see at the bottom of this page. So the ISO of the Leica system should actually be dialed in as the ISO chosen for the Hasselblad system times crop factor squared, which is 0.79 squared. And that yields an ISO of 40. So if I look at the two triangles, now they are compatible and the ISO 40 is what I should choose, but that's not what I want, because at ISO 40, as I just mentioned, I will see very likely a decrease in image quality and dynamic range because it's smaller than the base ISO of 100 on the Leica SL3. Very important to bear in mind. That's why I want to change that to an ISO of 100, which kind of messes up now my equivalent exposure on the two light triangles. By the way, as a side remark, if you wonder about that formula here at the bottom with crop factor squared yielding an ISO of 40 in order to make exposure equivalent, let's have a look into PhotoPills again on the iPad to verify that 40 is the right number. And what you see here is there is a section in this iPad app where I can calculate ISO by prescribed parameters on two cameras. And I did feed here in for the Hasselblad the f8.0, shutter speed of 0.5 seconds, ISO of 64. And for the Leica an aperture of f6.3, shutter speed again of 0.5 seconds. And then the app calculates for me an ISO of 40, which should be applied to the Leica system in order to get equivalent exposure. And I just wanted to show this, so if you find some of my formulas here interesting, best case, worst case, confusing, then there's always a way with an app somewhere on the web, for instance, or on the iPad or the iPhone or Android phone to verify this. And with PhotoPills, you see exactly how this works, and 40 is the correct ISO value to make these two light triangles here exposure equivalent. So if these two light triangles, as just proven, are now exposure equivalent, but I want to replace now the ISO 40 by the Leica's base ISO of 100, how would that look like? And the only free parameter I have now is the shutter speed. And so far we have assumed we apply on both camera systems a shutter speed of half a second, because the aperture is dictated to me by the depth of field equivalence. The focal length anyway was dictated to me by the field of view equivalence. The ISO is dictated to me by shooting at the native or base ISO. So the only free parameter I have here is the shutter speed. And if you think about that, if we increase ISO from 40 to 100 to the base ISO of the Leica on the right hand side, we need to compensate for brightness via shutter speed. And if we increase an ISO value from 40 to 100, this corresponds to 1 plus a quarter stop. Namely 1 full stop from an ISO of 40 to 80 and a quarter stop from an ISO of 80 to 100. So that's actually what we have to apply now to our shutter speed in order to get the exposure on the Leica light triangle on the right hand side again equivalent to the exposure on the Hasselblad light triangle on the left hand side. And if we do that math and the calculation, it takes us to 0.2 seconds instead of 0.5 seconds. And again, we can verify this with this ingenious app PhotoPills, which I can only strongly recommend to have on your iPhone and your iPad at all times. Because here we have also a section where we can not only calculate the ISO as I showed before on the screenshot, but also the shutter speed. And again, we feed in the aperture, 8.0 for Hasselblad, 6.3 for Leica. We feed in the shutter speed on the Hasselblad system of half a second and an ISO of 64, which is the native ISO. And we now feed in also an ISO of 100, which is the base ISO for the Leica system. And then the app calculates for us, in order to get equivalent exposure on both light triangles, the shutter speed, and voila, it's 1/5 seconds, which is, as I just figured out, 0.2 seconds. Now we have all ingredients for a proper comparison, and let me quickly summarize what we have here, because that is almost the end of my part 1 video of my comparison of the Leica SL3 and the Hasselblad X2D. First of all, focal length 21mm on Leica versus 25 on Hasselblad. Aperture f6.3 on Leica versus f8.0 on Hasselblad. ISO on the Leica, we choose the base ISO of 100, and on the Hasselblad we take the native ISO of 64, and that's because we want to make sure that no one comes around the corner and says, well, if you would have shot this all with base or native ISO, the outcome would have been different. Let's go for the setting on ISO, which naturally yields the best dynamic range and the best possible image quality. And then we have a shutter speed of 0.2 seconds on the Leica system, 0.5 seconds on the Hasselblad system, and last but not least, in order to avoid anything funky going on with white balance set on the cameras, I will fix the white balance to 5000 Kelvin on the Leica as well as on the Hasselblad. Of course, we also shoot with self-timer and in fully manual mode, and I think I want to quickly show how to set the white balance on both cameras, and then I conclude the video. Let's have a look how to adjust the white balance to a manual setting. So on the Hasselblad, I most of the time have this on auto white balance and the camera gets the job done. So I like that, but here I wanted to avoid any funky effects coming from auto white balance and what the camera decides for. And there is here, besides all the settings like cloudy, shade, daylight, tungsten and so on, you have manual white balance. And then you can tap here and then you can adjust here your temperature. And I wanted to have this on 5000. I think this perfectly fits here into the studio atmosphere. On the Leica SL3, not that much different. You have here in the screen a field which you can tap. Let me look into that here. And then you have, again, in the same way as on the Hasselblad, all kinds of settings, you know, flash, you have here tungsten, shadow, cloudy and so on. And also here I have this most of the time on auto white balance. But now since I have 5000 Kelvin on the Hasselblad X2D, I also need to adjust this here. And then the temperature is manually set. And that works here. And you see I can here toggle between different temperatures, and 5000 was my choice. So this is the outcome, and you've seen this already in the little quiz at the beginning when I asked you to guess which side is from Leica and which side is from Hasselblad. If you look at the shooting parameters here on the left hand side, on the Leica system, 1/5 seconds, that's the 0.2 seconds I mentioned before. Aperture f6.3, base ISO of 100, 60.3 megapixel. I'll talk more about resolution in part 2 of my comparison. And on the right hand side, the Hasselblad system, 0.5 seconds, so half a second at f8.0, native ISO of 64 and close to 102 megapixel. And these images look kind of the same, right? I mean, you don't even see big differences in color here. Of course, if you go into 100% crop, you see that the Hasselblad has significantly more resolution. And Jennifer's face here is sharp and in focus. actually the whole body, because I was stopping down to f8 on the Hasselblad system and to f6.3 on the Leica system. This is sharp and in focus, but the background blurriness is still there. What you see at the bottom here, if I leave this view here, is actually a lot of more images, because in part 2 I will talk about dynamic range. I will overexpose images, underexpose images, will compare them side by side between the Leica system and the Hasselblad system, and so also gain some insight into the capabilities of the sensors. Alright, that concludes part 1 of my comparison of these two camera systems. And don't miss part number 2, which will be posted in a couple of days, and where I go deeply into all the similarities but also differences of these two camera systems. And this video here was necessary, part 1, because I needed to lay out the foundation. I think having such a long technical part in a comparison video is just tedious, and I thought it's better to split it out and have it as part 1, providing the technical background of all I'm going to test in part 2 in terms of dynamic range, image quality, sharpness, all of that, and in this way having a proper sequence and segue from part 1 into part 2. If you liked that video, don't forget to drop me a thumbs up. Stay tuned on my channel, there's always more to come. Thanks for watching, stay safe and healthy, and of course, peace out.